Thank you very much for getting back promptly after the break. It'll help us keep on schedule and we give the speakers enough time. So, again, for the planning for next year's conference, we have another polling question here. We'd like to know how many repeat customers we have. So is this the first time you've been to this conference? First out of 13? 1 to 2? 3 to 5? Or 6 or more? And so you can text 2A, 2B, 2C, or 2D to 56418. So it'll help us see, again, how we do on getting repeat people here. So I hope you were able to see the technology showcase outside and talk with the vendors we have, as well as some of the AT&T booths, and make contact there and perhaps set up some meetings for afterwards based on that. All right, so the results are starting to roll in here. Oh, wow, almost half are first time. Oh, and some 10% have been here quite a bit. Okay, excellent. Oh, that's very interesting distribution. All right, oh, it's starting to change a little bit. Okay, so we'll, folks can keep doing that, and we'll gather the data because even if we don't see it all now, will still be useful for us as we're doing our planning. Okay, so our next speaker is Brian Rexroad. Brian Rexroad functions as a network security analyst and is the technical lead for a multidisciplinary team that develops processing systems to analyze internet activity for leading indicators of security events. Events of particular concern include distributed denial of service attacks, network worms, and botnets. Based on his knowledge of security attack methods and trends, Brian also provides a role in service concept development, strategic planning, and cross-project coordination to create security services that help protect AT&T's customers against these threats. Brian's professional work experience spans over 25 years in many disciplines of information security and network security within both commercial and high-assurance government contexts. He joined AT&T in 1995 after 8 years of civilian service with the Department of Defense. Brian is an NSA-certified information security analyst. He earned an MS in electrical engineering from Johns Hopkins University. He earned a BS in electrical engineering from Penn State University. Please join me in welcoming Brian Rexroad.
Thanks, Gus. Thank you, Brian. Well, thanks for joining us today. I appreciate the opportunity to speak with you. What I will be talking about is an adaptation that we're working on to facilitate doing some of the types of analysis we've been doing in the context of internet and adapting that to the mobility environment. And I'll help describe that, the context around that as well. So, in the words of Willy Wonka, we have so much time and so little to do. Let's reverse that. We don't have much time, actually, so let's move ahead. Just in case you've been living under a rock, and obviously these folks that are here are not living under a rock, but obviously the sophistication of mobility devices is significantly increasing. Their capabilities are increasing. There are a number of things, the increased amount of memory, that means more stuff on devices. The processing capabilities are getting more powerful, and in fact, I think one of the most significant changes that's happened recently is the fact that devices are becoming multi-processing capable. And so basically what that means from a security standpoint is things can be going on in the background. They're not visible to you as a user. And obviously another aspect of this is that over the course of about 3 years, there's been about 3,000% increase in the amount of data traffic on the network associated with mobility. That's a significant growth. We expect that to continue as well. So just to put another sort of essence of context around this, look at the data rates and how they've been changing over time. What I find kind of astonishing is the transition between 2005 and 2011 that's shown on the graph here, where we have a theoretical peak around 300 or so kilobits per second in the 2005 timeframe, where the mainstream is up around 7 megabits per second in the 2011 timeframe and going forward significantly. Now, how does that happen? Well, obviously, we've been adding additional spectrum to the extent that it's available. We're adding more cell sites so that the cell sites are smaller and we have more capacity in that sense. But there is still more that's related to this. One thing is that we can't change the laws of physics. The fact of the matter is what's happening is there is a change in the way access is being provided to the radio portion, the spectrum portion of the network. And whereas in the past it had been long-term, slow channels that were created to support voice transactions, as we get into the data environment, we want to be able to provide very fast and short transactions and do many of those. So what that means from a security standpoint is that if you have many, many users trying to do long, really fast transactions, you end up with a contention in the bandwidth spectrum. Again, we can't change the laws of physics. Another aspect that's kind of unique to the mobility environment is that whereas we've typically had in the wireline environment a circuit switch network that works somewhat autonomously, we have an IP data network that works somewhat autonomously. They all work and have their own level of sophistication associated with them. When we talk about it in the context of a mobility network, all those pieces need to work together in concert because they have to access the same radio access network and they depend on each other. And in fact, this is actually a very watered down version of the view graph that I wanted to show you here. We have actually a diagram that shows literally, I would say, on the order of about 1,000 lines that are interconnecting between all of these boxes. But let's just take a look at these. First of all is a transport network. Transport actually is becoming more structured as we continue with the merger benefits of the mobility environment with the traditional wireline environment. So that is a continuing activity that we have going on. So that's a good thing. In terms of the radio access network, we've already talked about that to some extent. There is a potential for bandwidth contention in that area. The circuit switch network has been around for quite some time. It will be around for a while longer, but as time goes on, what we can expect is a lot of that activity is going to move down to the right side there where we have the integrated media services. And so more voice over IP is going to take place. That will be extended out to handsets. And so what we can expect are new types of scenarios that we don't anticipate today that we might encounter from a security standpoint. Obviously, subscriber management is an important aspect of a mobility network in the sense that if we don't know where you are, we can't connect a call to you. So we need to be able to track the location information, and we also need to be able to protect that information. That seems relatively straightforward, but when you start roaming into other networks, we need to be careful about what the transactions might be with other networks and what they know about you from a location standpoint. In the messaging core, messaging is a short messaging service. Actually, a little known fact is that the transport for the messaging core is not an IP network. It's not an internet-based service. It actually transports over the traditional signaling system 7 network. And so in that context, we need to be paying attention to the functions associated with that. There was an exploit that was exposed about a year or so ago associated with iPhone that was related to being able to send messages to the iPhone through SMS that had obviously some derogatory effect. I think Patrick McKenna will be talking about some more SMS-based things later on. We talked a little bit about the integrated media services. I'll go and talk a little more about packet services. This is basically access to the internet. So what's different about mobility? First of all, the internet-facing IP addresses that are assigned there aren't really enough IP addresses to go around. That is, as we have more and more users trying to access the internet, the addresses are assigned very dynamically. As we move to IPv6, that will change. So there's a yin and yang associated with this. As we start out, we have very controlled access to the internet, and there's in fact very little capability to connect from the internet to a mobility device. It keeps the mobility device very much as a client device. But user demands are going to say, well, we want P2P type services. We want to be able to get, in fact, there may be circumstances where you want to treat a mobility device as more like a server. And so there will be a requirement that we anticipate to be able to provide more connectivity to mobile devices from the internet. But for the time being, we're operating in somewhat of a reprieve. That is, there is effectively in the mobility network a firewall built that helps to protect your device from some types of activities. there's more diversity in the operating systems that exist. And so whereas there is an existing base of malicious tools that can be used to attack the traditional devices that sit on desktops or we carry around as laptops, that sort of capability doesn't exist today, and it's more difficult to develop new tools against a more diverse set of operating systems. That, again, will also continue to change over time. And in fact, there are a lot of efforts to try to standardize how applications can operate between systems, because obviously the application developers don't want to have to create a special port to all of the different devices. We have what I would describe as starting out with low-value transactions. That is, if you look at a lot of smart devices that are in existence today, the types of transactions that are taking place, it's not your strategic planning type activity. It's not engineering for intellectual property and developing a lot of technical intellectual property, for example. Most of it is actually, well, where's the nearest restaurant? Can I find directions for this place? And so as time goes on, as more applications, banking transactions are taking place, we can expect there will be more motivation to try to target those devices for data theft or other types of activities. And then last but not least, there are some application controls in place today. That is, if you go to the official marketplaces for applications, there are some mechanisms in place that can remove applications that have some derogatory effects. And so we want to keep that capability around as much as possible. But as more diverse marketplaces become available, as, for example, in the iPhone case, if the device is jailbroken, it allows going to other diverse marketplaces, which basically detract from that capability. So rather than wait for the problems to occur, we're anticipating the types of problems that might occur. And one thing I should point out in particular is many of the prototypes associated with creating a botnet in a mobility environment don't limit themselves to using the IP network or internet access for their command and control. They would also potentially use the SORT messaging service, for example. So we basically have an existing platform starting from the upper left-hand corner here, where from the wireline environment, we are collecting metadata, primarily flow data, into an existing threat analysis platform that we're using to process that data, identify early indicators of threats, identify botnets, track those botnets, and understand what they present in terms of a threat to our services. And then there is also an existing operations and analysis team associated with that to work with response activities, as well as the capability to build signatures so that we can introduce those as part of the services we provide, specifically the security services that we provide, so we can detect those events or detect events specific to your environment, as well as to facilitate blocking. So what we are adding actually in the bottom left-hand portion here is the capability to introduce some attributes associated with the mobility environment as well. As I mentioned earlier, IP addresses are assigned very dynamically in the mobility environment. So if we were to look at mobility activity associated with those IP addresses, it would be very difficult to correlate that activity with the specific actors that are associated with it. In particular, IP addresses can be assigned in a matter of seconds or changed. So it's important that we have visibility from the mobility perspective so that we can associate that with specific devices. And I'll show you an example in a moment. And also, as I had mentioned, the SMS portion of the network, and this is a simplification, there are other aspects as well. But again, we anticipate that botnets are going to attempt to use SMS as their command and control. There's also the threat of distributing malicious applications through URLs that are conveyed through SMS. And so having the capability to analyze for those, filter those out, or identify the threats and be able to block those is important. So this is just an example to try to convey what value we get from this type of information. This is actually an example from the wireline environment. It's not mobility related at this point, but I just wanted to at least illustrate what the kind of thing that we get. So what we're looking at here on the Y scale is the number of sources, that is source IP addresses, unique IP addresses that are scanning on an hourly basis on port 23. Port 23 is used for Telnet, which is basically a remote login. And what we're seeing here is a trend, and this is looking over about a 60-day period from around the beginning of March to the beginning of May here. And you can see that there's a clear trend. The orange line is one that I drew on there. A clear trend increasing in terms of the number of sources that are doing that scanning activity. What that basically is indicative of is a botnet. That is, we don't see a big change in the number of sources that are doing scanning, and you can see that there are obviously some spikes in that area. You don't see a big change in an abrupt sense like that, and then changes also turning off without having some central command and control associated with it. So this is one of the mechanisms we use, or one of the trends that we use to help identify botnet activity on the network so that we can identify the command and control and then continue to track that and mitigate it if it's possible. So we expect to do the same type of analysis in the mobility environment. Now, here's actually a quick introduction into some activity that we have going on with mobility right now. That is, we have a development feed for a sector of our network at this point, and it's related to the Droid Dream event that took place a couple of months ago. So around March 2nd or so of this year, basically what happened is about 50 applications that would otherwise have been innocuous or actually valid applications, legitimate ones. They were Trojaned, that is, malicious code was put into those. They were snuck in or introduced to the official Google Android market. And as a consequence, some devices were infected from downloading those applications. And the response was basically to send a kill switch. That is, because it came from the application market, they were able to remove that application from the market so others wouldn't be infected, and then basically push a patch out to the devices so that it would remove that application. Now, ideally, what would have happened is all the devices would have been eradicated. But as it turns out, as we have a couple of data points from the end of March and also from the end of May, there are still some lingering devices. Now, to quantify this, we're talking about, really millions of customers that have devices like this, but only about 80 or so that have particular types of infections. So that's not a significant issue, but what is significant is the fact that we're able to identify specific devices that are infected. We'd be able to work with customers to notify them. We have been working with Google to see what can be done to make this a more effective mechanism. And by the way, this analysis is credited to John Hogeboom, and there's actually some more detail on this analysis that'll show up, I think, in a webcast recording that'll show, I think, at the tail end of lunch. So what I'd like to do is leave you with some tips. This is actually based on something I pulled from CERT. It's really a device-oriented thing, so that in terms of thinking of what you can do for yourself, obviously, if we can reduce 10,000 bots, which is obviously something that we'd be concerned about, if we could reduce it to 9,000 because people are aware of what their devices are doing and using good practices, then we've obviously put a small dent in the problem. But we anticipate we still have some work to do there as well. The one thing I would like to point out, rather than walk through each one of these, is simply to say that we have a culture shift that we need to adopt, and that is that these devices aren't static anymore. We need to update them. The applications need to be updated. The operating systems need to be updated on a regular basis for security purposes. Questions?
Great. So thank you, Brian. Do we have questions? We have time for a couple of questions. Oh, come on. This is a quiet crowd. We got to get some questions somewhere. We didn't. Okay. Thanks.
Hi, the CETA organization is your threat detection or threat analysis team. Yeah, they don't have any endpoint. There's no endpoints as part of the sensors that you're using. Do you find that that's going to change, given what you've demonstrated here?
It's actually what is conveyed in that diagram, and I can go ahead and back to it. I think that's a very good question. So CETA is the Security Event Threat Analysis Service, and typically the way that service is put together is we bring in feeds from customer devices or devices that AT&T manages into a platform, provide analysis for that. What this is intended to convey is signatures that we will be providing based on the threats that we identify in the internet. So that would include botnet command and control, APT drop servers that we've identified, for example, as well as a number of other threat entities that we would consider to be ones that you should be concerned about. And that will result in the CETA service, for example, as an alert that we'd be able to convey to customers and to help mitigate that threat. Thank you. That's a very good question.
Other questions?
Okay. Once again, thank you very much.
Brian, thank you. Excellent. That was very good.